everyone, we are Columbia Space Initiative and we are MicroG team, and here is our line drill, the device we're doing and prototyping. And my name is Mike Karasif and I'm the co-lead of the team.
My name is Saad Salim and I'm also a co-lead of the team.
My name is Robert Kidd, manufacturing engineer.
I'm Alex Kim, I'm the financial lead.
And we're going to show you the details of our device right now.
Over here we have the sand assembly. So we have the main body, a sample tube, the operational handle, and over here we have the sandstone assembly, which consists of a core drill bit, and here's a prototype of the turbine, which we are going to be machining out of aluminum.
Okay, so here I'm going to talk about the sandstone operation. Here we have a prototype of the turbine. We'll eventually manufacture with aluminum, but this is basically a prototype. It will be roughly the same size. And basically how this turbine works is, as any turbine does, you channel air through this channel, and then it spins the turbine, and then air comes out of this channel. And we're going to attach a rod through the center of the vanes of the turbine and attach it to this chuck, which is also attached to this diving core bit. And basically once we attach the rod, we can flip it here, flip it around, and it's going to be in this orientation. And once we attach the rod and the turbine spins, the core bit will spin as well. And we're basically going to create handles that we can push the core bit down into the sandstone, drilling the sandstone.
So over here we have the sample tube. This is used to hold a sand sample. It's 8.5 inches in height and the inner diameter is 1 inch, so you can get the correct size sample. The way we can open and close this is this iris mechanism on the bottom. Turning the top opens and closes the iris. And the reason for these extrusions is to fit into the main body of the device. And the way we can drive the turning is with these 3 holes on the top and a piece called the operational handle. The operational handle looks like this, and the way it works is you insert it here, and by turning it you can open and close the iris. The reason we have the cylinder here is because the turbine with the drill chuck will fit directly into here, and that is how the sample tube and operational handle works.
So to review the sand assembly, first of all, to get everything together, we take the sampling tube and then we put it inside of the sand body of our device. So we put it like this. We accurately put it inside until it fits correctly. And now we scroll it a little bit and it fits into the holes inside, so that sampling tube holds inside of the body, and that if we rotate the central piece, the iris is going to open and close. Then we're going to feed the operational handle on top of our sand assembly like this. So we take the operational handle and we connect it together. It's going to be connected, but right now we still need to calculate some of the angles. But it's going to be one solid piece at the end. And then we put it inside of our device. We put it like this. And we feed the extrusions on the operational handle, these extrusions, to fit inside of the sampling tube, inside of the 3 holes, fit a little bit, and then we feed the operational handle on top. Feed the operational handle on top of the device, like this, and during the operation, it's gonna be closed, but when we finish the operation and when the sample is already inside of the sampling tube, then we just rotate the operational handle, and it will close the sampling tube from inside, and then we push the operational handle to the bottom. We push it to compress the handle inside of the sampling tube.
Hello, so this is going to be the sand assembly that we have. So basically the turbine is going to rest rigidly on here, and it's going to be connected with these latches at the sides. And from there, since it's not going to be powered during the sand operation, but it will be manually powered, and we'll also have side handles protruding from here to apply rotation.